Hey all, welcome back to my channel Hired Ready. In today's video, we are going to see clearly about multiple linear regressions, real world applications. Every concept you learn, every topics you dive in. The one important step that you must do is you should learn about their real world applications. Only if you learn about how it is being applied in the real world, it will be helpful for you in making a career out of what you are learning. So, without any delay, let's get started with real world applications of multiple linear regression. In the previous video, we have already seen what exactly is linear regression, what are their real world applications. We have already seen how to do a hands on project, end to end project just with linear regression. So, this video is about real world applications of multiple linear regression. So for every case study that we are going to see in this video, we'll be having a problem statement. We'll be seeing what is that dependent variable and we'll be seeing what are all those independent variables. We'll see column-wise clear explanations. What is the meaning of a particular column? We'll be seeing about hypothesis, null hypothesis or alternate hypothesis. If the changes is going to happen or it is not going to happen. Finally, we'll be seeing steps to solve using multiple linear regression. Without any delay, let's get started. The first step of multiple linear regression is definitely the problem statement. So in this case study of house price prediction, the problem statement will look like this. Real estate companies want to predict house prices based on multiple factors like size, location, and age of the property. Now, this is my target, predicting house price. Obviously, house price column is going to be as my target variable. In such scenario, what is my dependent variable? The target variable is also called as dependent variable. Why? Because that is something we are going to predict using independent variables or features. Now, for this problem statement, what are all those independent variables or features? Area of the house, bedrooms, number of bedrooms in the house, number of bathrooms in the house, location score. If my house is located near to any city, it will be getting a location score of around 9 or 10. If it is far away from a city, then it will be getting a location score of around 4 to 5 or something. So based on this, I can clearly understand if I could relocate to this house or not. So it definitely gives a major contribution towards the price of the house. In city side, the cost of the house is obviously high, but in village sites, it's obviously very less. House age, how many years it's been after they built this house. So using all these columns, I'm going to predict my particular target variable house price. This is how this particular problem statement works. So in this, now let's try to understand the meaning of these column names. This problem statement is quite easier. So column names is something that you could easily understand. So house price is something final selling price of the house. Area means total square footage of the house. Bedrooms means number of bedrooms in the property. Bathrooms is about number of bathrooms. Location score. Rating of location based on amenities, transport, and schools. House age, number of years since construction. Now we have clarity about all these things. The column explanations, dependent variable, independent variables. Now let's try to create a hypothesis with this. The thought process about how the solution of the problem could look like. For this, the null hypothesis, the changes could not happen, that could not possibly happen is like house price is not influenced by other features. All these independent variables. This is my null hypothesis. Then for alternate hypothesis, this is going to be straight against this null hypothesis. So what I'm going to have is alternate hypothesis. House price significantly depends on these features like house price, area, bedrooms, bathrooms, location, score, and house age. For solving such kind of problems, what are all the steps we'll be using? We might think in the previous video, we have seen some steps common for multiple linear regression based projects. But to be honest, based on the type of a problem, the number of steps or the key steps will differ. So for this kind of problem statement, my first step is about collecting my housing data set. The second step is cleaning and handling the outliers and missing values. The third step is performing EDA, exploratory data analysis. The fourth step is about selecting important features. The fifth step is splitting data set into training and testing sets. Sixth step is obviously training my ML model, multiple linear regression, machine learning model. The seventh step is all about evaluating my model's performance with the evaluation metrics like R-square or RMSE. The final step is interpret coefficients to understand price drivers. So this is a common step that we'll be using for understanding this kind of problems. I believe you have clarity about this kind of case study because we have already seen this. Now for this we got some more additional features. Now let's get into another case study. Sales prediction, retail and e-commerce. This is the second case study that we are going to see now. So in such scenario, what could be the possible problem statement? Companies want to predict product sales based on marketing and pricing strategies. When I hear the word sales prediction, we can clearly understand the problem statement is definitely going to be about predicting my future sales based on the historical and present data. So in such scenario, what is going to be my dependent variable? Sales column is going to be as my dependent variable. So for this particular data set, what I could possibly have is independent variables. TV advertising. If I want to increase the sales, what are all the steps that I could possibly take is going to be as the independent variables in such scenario. TV advertising, social media ads, price, the comparative price, the discount, store traffic, the number of people who is visiting our particular store. These features decides my sales, how the sales is going to get increased or decreased. This is something that I could decide based on all these features are independent variables. Now, let's try to understand all these columns. So, in column explanation, it is going to be easy for you to understand because this is actually a simple problem statement, right? So, sales is about total units sold based on my product that I'm selling. TV advertising, it is about budget spent on TV advertisements. Social media ads, this is like advertising budget that we choose for social platforms. Price is definitely a selling price of any products. Discounts says everything about the percentage discount offer. If my cost of a product is around 500, if I give 50% discount, the cost of product could become 250. So this attracts customers to visit my store, so it could increase my sales. Then store traffic, number of people visiting my store in the historical data and present data. So number of customers visiting the store or website. So for this kind of problem statement, what could be the null hypothesis? Advertising and pricing strategies do not affect sales. This is going to be as my null hypothesis. The possible alternate hypothesis for this kind of problem statement could be obviously advertising and pricing significantly could influence sales. So what I'm saying in alternate hypothesis is these features could influence my sales, but in reality, definitely these features could influence sales. But here, the problem that we are going to solve is like predicting if this data is really helpful in predicting my sales or not, based on the data that I have, based on the particular store's data. So for this kind of problem, what are all the steps that we will be using to solve this problem when it comes to multiple linear regression? The first step is obviously collecting the historical marketing and sales data. The second step is pre-processing the data set, handling missing values, encoding categories. So all these steps will come under the second step, because in this particular data set, encoding is necessary. Why? We could have 5 or 6 type of products. We could even have 100 types of products. So if I train my ML model with the name of the products, it cannot clearly understand and predict. The process becomes quite tedious. So in such scenario, if I rename the categories or rename that alphabetical characters to numbers, my model could perform easier, because my system clearly understand numbers better than an alphabetical character. So that's that particular step we'll be doing here. The third step is performing EDA to find relationship between ads and sales. It is about creating charts to understand how sales are changing based on all these columns. You could even create individual charts. You can even create combined charts. The fourth step is identifying key predictors. Which particular column is affecting or influencing my sales more? The fifth step is training my particular model. This is the important step. With my given data, I'm going to train my model. The sixth step is evaluating my prediction accuracy. So this is like checking my model's performance. So this is my sixth step. The final step is using model to forecast future sales. After building all my model, I'll be deploying it, right? So what is going to happen now? My model is capable of predicting my future sales based on whatever data I'm going to give. So this is how generally the case studies of multiple linear regression will look like. So today we have seen 2 case studies. In tomorrow's video, we'll be seeing 3 more case studies to understand how powerful it is regression algorithms. Tomorrow we are going to see 3 more case studies for multiple linear regression. Only if you have clarity about real world applications, you can get clarity and you can do all your project on your own. That is why I'm giving so much of importance to this. So if you completed this day of the course, make sure you mention the day and post it completed on the comment section. So bye for now. We'll meet you in an amazing video tomorrow. Bye.